Okay, let's dive right into this. Welcome to The Explainer. Today, we're taking on a massive buzzword you probably heard 1,000 times, but let's be honest, you might still feel a little foggy about. We're talking about blockchain, and we are going to decode blockchain technology from the absolute ground up. I promise you, by the time we wrap up here, we're going to demystify this entire concept. I mean, breaking it down so clearly that even a 10th grader could turn around and explain it to their friends. So let's get started. To do this, we're going to use a sort of peeling the onion approach in 5 simple steps. 1. What is blockchain technology? 2. History and real-world applications. 3. Under the hood, blockchain architecture. 4. How networks reach a consensus. And finally, 5. Cryptography and hash functions. Starting off with Section 1. What is blockchain technology? To really understand this technology, we first have to look at a fundamental problem with traditional systems. Just imagine trying to guarantee a financial transaction, or, say, secure a highly sensitive digital file, completely without a central boss. No bank, no government agency, no CEO acting as the middleman. How in the world do you build trust between total strangers? Well, historically, you just couldn't. You absolutely needed that intermediary to stamp the paperwork and say, yep, this is valid. That is, of course, until blockchain came along. The brilliant solution to that problem is what we call a distributed digital ledger. At its absolute core, a blockchain is really just a system that securely records transactions across multiple computers. The data is stored in blocks, and then those blocks are chained together in chronological order. Think of it kind of like a shared online document for a group project. Instead of one person holding a Word file on their laptop and nervously emailing versions back and forth, everyone in the group is looking at the exact same document at the exact same time. If someone makes a change, everyone sees it instantly. But the kicker with blockchain is, once that change is verified and recorded, it is locked in forever. No takebacks. Because of that highly unique setup, blockchain actually has some serious superpowers. It operates on a peer-to-peer network, which literally means users exchange data or assets directly, completely bypassing any central authority. And that leads to much faster verification and drastically reduced fraud, mostly because everyone has eyes on the ledger at all times. It also features things like smart contracts, which are essentially just self-executing digital agreements, and intense cryptographic hashing to guarantee high data integrity. It's basically an automated trust-building machine. Moving right along to Section 2, History and Real-World Applications. Let's see how this revolutionary idea actually evolved from a simple concept on a chalkboard into a massive global technology. Now, a lot of people think blockchain was just invented yesterday, but the concept actually goes way back to 1991 when researchers Stuart Haber and W. Stornetta proposed a cryptographically secured chain of blocks. Honestly, it was purely academic until 2008. That's when the mysterious Satoshi Nakamoto published the famous Bitcoin white paper, bringing blockchain to life as the foundation for the very first peer-to-peer electronic cash system. Then, around 2015, things really exploded when Ethereum introduced smart contracts, allowing developers to build entirely decentralized applications that went way beyond just currency. And today, well, we are hurtling towards a fully decentralized future, where blockchain is the absolute backbone of Web3 and modern digital identity. Which brings us to a super important realization. When you hear the word blockchain, you probably immediately think of cryptocurrency, right? Like Bitcoin. But crypto is just one single application. This technology is actively transforming supply chain management, literally tracking shipping trucks and preventing counterfeit goods from hitting the market. It is revolutionizing healthcare by securing your private medical records so only your authorized doctors can even access them. It's reshaping traditional banking, and it's even providing secure digital identities for people all around the world. It is so much bigger than just digital money. Let's jump into Section 3, Under the Hood, Blockchain Architecture. Now that we actually know why it matters, so the crucial point is, we need to peel back the next layer to see exactly how this architecture actually stores and secures all that data. The foundational structure here is called Distributed Ledger Technology, or DLT. Remember our group project analogy from earlier? DLT is the structural framework that makes that shared document possible in the first place. Its main job is to totally eliminate the single point of failure that you'd normally find in traditional centralized databases. Think about it. If a bank's central server goes down or gets hacked, that is a massive problem. But with DLT, there simply is no single central server to attack. So instead of one central hub, the data is distributed among all participant nodes. And a node is just a fancy word for a computer connected to the network. Whether there are 5 nodes or 50,000 nodes, every single one of them holds a perfectly synchronized copy of the exact same ledger. When a brand new transaction happens, it gets broadcast out to all these nodes, they validate it, and then the ledger updates everywhere, all at once. It really is the ultimate form of transparency. Section 4. How networks reach a consensus. Now, this introduces a massive, entirely logical question. If every single computer on a global network has a copy of the ledger, and there is no central boss in charge, how do all these separate computers agree on what is actually true? Well, the answer is a consensus mechanism. You can think of this as a very strict set of built-in rules that absolutely every computer must follow. A consensus mechanism is a process that allows all network participants to agree on the validity of new transactions. It's incredibly important because it prevents things like double spending, ensuring you literally cannot spend the same digital dollar twice. By forcing agreement among the nodes, the consensus mechanism ensures that every single copy of the blockchain remains perfectly identical and entirely secure. And this brilliantly illustrates the two main ways networks actually achieve this agreement: proof of work and proof of stake. In proof of work, which is what Bitcoin uses, miners use massive amounts of computing power to solve incredibly complex mathematical puzzles. The first one to solve the puzzle gets to validate the block. It is highly, highly secure, but it consumes a massive amount of electricity. On the flip side, proof of stake, which Ethereum 2.0 transitioned to, is a much more modern alternative. Instead of burning energy trying to solve puzzles, validators are chosen based on the amount of cryptocurrency they are actually willing to stake or lock up as collateral. If they approve bad transactions, they lose their money. Simple as that. It's faster, it's incredibly energy efficient, and it achieves the exact same goal of decentralized trust. It is also worth briefly noting that while proof of work and proof of stake are definitely the most famous, there are other methods out there too. Systems like delegated proof of stake use user voting to elect validators. Proof of authority relies on pre-approved, trusted validators, which you're going to see a lot in heavily regulated industries. And practical Byzantine fault tolerance is frequently used by massive private and enterprise blockchains. The exact method might change, but the core goal is always exactly the same: achieving total agreement without a central leader. Finally, Section 5, Cryptography and Hash Functions. We are down to the final layer of our onion, the mathematical magic that actually locks these blocks together so securely that they can literally never be tampered with. This is the realm of cryptography. Think of it kind of like a digital wax seal on an envelope. Cryptography is basically the science of protecting information by transforming it into a totally unreadable format. In blockchain, it uses a system of public and private keys to ensure that only authorized users can actually access or authorize a transaction. It also relies heavily on digital signatures. Just like you'd sign a paper check to prove you authorized a payment, cryptography uses complex math to provide a digital signature that definitively proves the authenticity and integrity of a transaction. But the true unsung hero of this entire system, the absolute ultimate security guard of the blockchain ecosystem, is something called a hash function. Honestly, if you take away just one technical concept from today, let it be this. Now, what's really interesting about this is how a hash function works. It takes any input data, whether it's a single word or an entire encyclopedia, and it converts it into a fixed-length, entirely unique code called a hash. For instance, notice what happens if your input is the word blockchain with a lowercase I. You get one very specific string of numbers and letters. But if a hacker tries to tamper with the data by changing that lowercase I to an uppercase I, the new hash output is completely, entirely different. Even the tiniest micro change in the data creates a drastically different hash value. And because each block contains the hash of the block before it, if someone tries to alter historical data, the hashes won't match up, the chain breaks, and the entire network instantly rejects it. It is literally foolproof. So, to bring it all home, blockchain really relies on 4 fundamental pillars. Distributed ledgers ensure the data is everywhere, completely eliminating single points of failure. Consensus mechanisms allow all those computers to perfectly agree without needing a central boss. Cryptography protects your data, your identity, and your assets. And hash functions mathematically lock it all together, making the entire history tamper-proof. Together, they combine to create a deeply trustworthy digital system in a world that desperately needs one. The sources make it incredibly clear. From finance to healthcare to global supply chains, the future is blockchain. But I want to leave you with this final thought. Are we truly ready for a fully decentralized world? Think about it, a world where you have total control, but also total responsibility over your digital assets and identity, without a bank or a corporation there to hit the undo button if you happen to make a mistake. It is a massive shift in how society operates. I encourage you to stay curious, keep learning, and start thinking about how this technology is going to reshape your daily life. Thanks for joining me on this deep dive.